All right, so this lesson we're going to start talking about rational functions and their asymptotes. And you guys completed a exploration on the rational functions and parts of the graph. So I'm hoping that's going to make this go a little smoothly. So a rational function can be written in the form f of x equals n of x over d of x, where n of x and d of x are polynomials. And I call it n and d because it's numerator and denominator. So anytime in this lesson where I'm talking about n of x, I'm talking about the numerator. D of x, we're talking about the denominator. Okay, so there are some things, new things that occur when we're graphing a rational function. One of those things that can occur is a vertical asymptote. And down here, if we're looking at the graph, this is a vertical asymptote. Right? And on the graph, it's going to be a dashed vertical line. And it is a vertical line that the graph approaches, but it does not touch or cross. Okay. Another thing to keep in mind with a vertical asymptote is that the function is undefined at a vertical asymptote. And so what happens on vertical asymptotes is you plug in that value and you get something like 2 over 0 or negative 5 over 0, which means the function is going to be undefined there because we cannot divide by 0. All right, and then as x approaches the vertical asymptote, so we get closer and closer to the vertical asymptote, the y is either going to go towards negative infinity or the y is going to go towards positive infinity. That's what happens on vertical asymptotes. All right, so now let's talk about horizontal asymptotes. So on this graph, this right here, the dashed horizontal line is a horizontal asymptote. And a horizontal asymptote is a horizontal line that the graph approaches as x approaches infinity or negative infinity. So as you go out to the left or to the right, the function is going to get closer and closer and closer to the horizontal asymptote. Now, one thing to keep in mind is that the graph can sometimes cross a horizontal asymptote. If this happens, it usually happens at the origin or close to the middle of the graph. But as you move away, the graph is going to approach the horizontal asymptote. As you move away to the left or right, that's what happens. All right, and then a hole in the graph is our last part that we're going to talk about today, and that is this right here. That's a hole, and it is an empty point in the graph where the function is undefined. Right, and what happens at a hole is you plug that value in, you get 0 over 0. So that is going to be a hole. So it works out a little differently. You still have 0 in the denominator, but it doesn't create an asymptote, vertical asymptote. It just creates this empty point in your graph. All right. So I have like a generic form of a function with the factors a or x minus a and x minus c in the numerator, and x minus b and x minus c in the denominator. All right, so one thing that I want you guys to notice is here, these x minus c's, they have in common, okay? All right, so I'm just gonna put a box around those. So let's talk about x minus a. X minus a is a factor in the numerator that doesn't have it in common, and what happens at a, you're going to have a 0 or an x-intercept. Well, they're the same thing, sorry. 0 / x-intercept. So what would happen in a function if you put a in, you get 0 over some non-zero number. And that creates an x-intercept in the graph. All right, then for your vertical asymptotes, this factor in the denominator that doesn't have the factor in common in the numerator is going to be a vertical asymptote. Right. And like I said before, if we put that value in, what we end up with is some non-zero number over 0. And when that happens, it creates that vertical asymptote. All right, and then the last situation is where we have these factors in common. So where x is equal to c, that's going to be a hole in the graph. And that's going to be the x part of the hole. And then to find the y part of the hole, you plug it into the reduced version. So you kind of kick out that x minus c. And then that creates the y part of the hole. And so on these, the f of c is going to be 0 over 0. So when that happens, you have a hole in the graph. All right, so I have the actual equation for this function that is graphed. All right, and so the first thing that I notice is that I have this x minus 5. All right, so that means that when x equals 5, you are going to have a hole in the graph. So the x part of your hole is going to be 5. And you can tell, like looking at that, that's where it looks like you have the hole. And you can kind of guess where you think the y part is, but we don't have to guess. We can plug that 5 in. Oops. All right, and so we end up with, that's going to be 2 times 3, so 6 in the numerator, 6 in the denominator. So that y is 1. So the hole, this hole right here, is at the point 5, 1. All right. Then, I know I'm doing this in a weird order, but that's okay. For the 0 or the x-intercept, we can already tell that it's right here. That's our 0 or our x-intercept. And that comes from this factor right here, x minus 2, not the actual 2, just the x minus 2. X equals 2 is a 0 or an x-intercept. And then for our vertical asymptote, we have this factor here that's not in common. So x equals -1 is our vertical asymptote. All right, now the horizontal asymptote is probably the hardest one to remember what to do. So for your horizontal asymptote, you're going to compare the degrees of the numerator and the denominator. And so if we have a situation where the degree of the numerator, which I'll call n of x, is less than the degree of the denominator d of x, then your horizontal asymptote is y equals 0. All right, if you have a situation where the degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote is the leading coefficient of the numerator over the leading coefficient of the denominator. And that's actually the case we have on this one. Even though I have these in factored form, oh, sorry, the wrong thing. I have these in factored form, it's going to be an x squared over an x squared. So it's basically 2x squared something over x squared something else. So the degrees are the same. So your horizontal asymptote should be 2 over 1, which is at 2, and that is where it's graphed. All right, and then the last situation is when the degree of the numerator is greater than the degree of the denominator. And when that happens, there's no horizontal asymptote, which is nice. for today, but tomorrow that might mean there's another type of asymptote that we're going to talk about that we would have to find possibly. Okay, so those are all the things that we're going to do. Now I have it all typed up in a whole bunch of words that I'm not going to read to you, but if you're doing this on your own and you just seriously get stuck, read those words. It pretty much tells you exactly what you're going to do. All right, so in all of these problems, the first thing we're going to do is factor. All right, and they won't all factor, so don't get super overwhelmed if something doesn't work out perfectly like you want it to. But this numerator is not going to factor. The denominator does. All right, so we are going to start off finding the domain. And we always factor to find the domain, and then anything that's going to give you 0 in the denominator is not in the domain. All right, then we would kind of pay attention to what would cancel before we do our vertical asymptote. Now on this one, nothing does cancel. So anything that would make you have 0 in the denominator is a vertical asymptote. All right, now let's talk about the hole in the graph. The hole is created when you have 0 over 0, or you have a situation where you have factors in common in the numerator and in the denominator. We don't have that here, so that's okay. It just means there's no hole, and that happens often. So don't get nervous if you have several with no holes. For the horizontal asymptote, we're going to look at the degree of the numerator and denominator, and I always go back to the original function before it's factored. That helps. So if you notice, the degree of the numerator is 1, and the degree of the denominator is 2. So the numerator's degree is less than the denominator's degree. And when that happens, that means that y equals 0 is the horizontal asymptote. All right, and that's it. So I want you guys to double check when you do these that your horizontal asymptote is a line. That's y equals. It's a horizontal line. If you just put 0, that is not a horizontal line. That is just a number. And then your vertical asymptotes are equations with x equals numbers because they are vertical lines. All right, so let's look at the next one. Let's talk about starting with factoring it. And we want to find the domain before we do anything else. We just factor, find the domain. Anything in the denominator that's going to make you have 0 in the denominator is not in the domain. All right, then I'm going to look and see if I have any factors in common, and I do. So I'm going to box them off. All right, and then anything not in the box that makes you have 0 in the denominator is a vertical asymptote. All right, and then the box creates a hole. All right, so I know the x part of my hole is going to be -3. All right, and then to find the y part, I'm going to take what's not in the box, and I'm going to plug in -3. So I get 0 over -2, or just 0. That is where my hole is. So in this graph, would just be going along, graphing it, and then at that point, you just draw an empty point. right, now I wrote this over too far. So let's talk about the horizontal asymptote. We look at the degree. The degree of the numerator is 2. The degree of the denominator is 2, so they have the same degree. So that means we're going to do the leading coefficient of the numerator over the leading coefficient of the denominator, or just y equals 1. Okay, so I'm going to go back and just make some notes. So on this the domains, this is before canceling, or we'll say before boxing. All right, this is going to be outside the box. The whole is going to be inside the box. For the X part. Oh, I need to reword that. So X is inside the box, and then Y is outside the box. And then for the horizontal asymptote, that's when you're looking at the degrees. Okay, so let's do a couple more. So remember, we're always going to start off by factoring. Right, when I find my domain before I do the box. So anything in my denominator that would make me have 0 in the denominator is not in the domain. All right, then I'll box off what they have in common, and I will find my vertical asymptote. So now outside the box in the denominator is the vertical asymptote. X equals whatever would make that 0. All right, then my whole, the X part of the whole comes from inside the box, whatever would make that 0. The Y part is going to come from outside, plugging that in. All right, so it looks like we're going to get 1 over -5. So -1/5 is the Y part of the whole, -1 is the X part of the whole. Right, and then the horizontal asymptotes come from the degrees. And again, I look at the, I look at the original. I usually look at the original. I have 2, 2. So they're the same. So I do the leading coefficient of the numerator over the leading coefficient of the denominator. All right, and then this last one, our numerator is not going to factor, or if it does, I can't see how to do it because of that. This skips from x to the 5th to x squared. If it had maybe been x to the 4th, I could try something, but with an x to the 5th, that's not going to happen. All right, and then our denominator, I know I can factor out a 3. And then that denominator can factor some more, because it is the sum of cubes. Now, one thing about the sum of cubes and the difference of cubes is this is always going to give you imaginary zeros, that part. So we are not going to worry about that messing with our domain or creating a vertical asymptote or hole or anything, that is going to be imaginary. So the only thing the x cannot be in this case is -2, because that would give us some non-zero number over 0. All right, and then, well, it will give you 0 in the denominator, period. The vertical asymptote is going to be that same because we don't have anything we can box off. And because we didn't have anything we could box off, there is no hole. And then for the horizontal asymptote, we look at the degrees of the numerator and denominator. So we have 5 in the numerator, 3 in the denominator. So when the numerator is greater than the denominator, that means there is no horizontal asymptote. All right, so I know that it's a lot to process. It's a lot of different things to remember. We will keep practicing, and we will learn some additional things tomorrow. And the directions on this assignment, I don't want you to do everything. Now, there are 3 of these that we're going to actually do. We're going to finish up the different parts, like the intercepts and the graph tomorrow. So I want you to make sure you do it, but on these, all we're doing is the A part, the C part, and the holes. Check. I'm pretty sure that's just going to be the domain, the asymptotes, and the holes. Exactly what we did on this assignment, or on these notes. Yeah, A, state the domain. B, we're not doing today. We'll do that with some of them tomorrow. C, find any vertical and horizontal asymptotes. And then I'm adding an additional thing I want you to do, and that's finding the holes. All right, and we'll keep learning some more stuff about these graphs tomorrow.